Britt Wray, thank you for joining me today.
Thank you for having me.
Ms. Wray, The Rise of Necrofauna, The Science, Ethics, and Risks of De-extinction. Wonderfully interesting book. What prompted you to write this and get interested in this subject?
Thank you. Well, many years ago, probably about 5 now, I heard that people were taking this idea seriously that they could potentially bring extinct species back to life. And they were people with deep connections to high-tech genetic sequencing companies and basically folks who have the know-how to apply advanced technology to ancient genomes of animals in order to potentially do something like this. And I thought, oh, wow, okay, this is absolutely not the kind of approach to conservation biology that I'm used to, because I did a degree in biology and focused on conservation and how people are innovating in ways to try and protect endangered species. And this was something completely novel and also potentially concerning in terms of the unintended consequences that could come from doing this kind of work. But it also just didn't sound realistic. It sounded like science fiction. And I was extremely curious about how people and why people were taking this seriously. So I set out to make a radio documentary about it, actually 3 radio documentaries about it. And this brought me to go effectively be a journalist on the ground, interviewing people who were at the forefront of this field, both for the project of doing de-extinction and against it. And I was just very fascinated with what they had to say.
Well, in reading this book, we often say it raises as many questions as it answers. In reading this book, it seems to me that it raises a lot more questions than it could possibly answer.
Right. Yeah, I think that's a fair thing to say. That was what I noticed when investigating this attempt to bring extinct species back to life. That the further into it that I looked at, it was becoming far more complicated than it at first appeared as a scientific ambition, either because of the technical hurdles that were there with the existing technologies or the biological realities of working with some of these species and their ancient genomes, collection of DNA that was available, or the ethical issues of what it would mean if these scientists were to succeed and get these animals back into the world in some way. Would they be able to actually rewild ecosystems that they hope to, or would these animals just end up living their existence in a zoo as some kind of captive curiosity that scientists had cooked up in a lab somewhere, all the way to how it interacts with human values and how to protect these animals. And yeah, the list goes on. But I would agree with you. It opens up more questions than answers.
How far along are we? I know in the book it mentions people trying to resurrect an ancient kind of zebra and an ancient type of cow or cattle of some kind. How far along are we on these things?
So there are different approaches to doing extinction, and in all cases, it's actually misguiding to say that de-extinction can resurrect an extinct species back into the world. Instead, we can create new animals that are close replicas or facsimiles of extinct species. And there's a variety of different reasons why, but they also largely relate to how these species are made. And it can be through cloning or genome engineering, or in the cases that you mentioned, it's backbreeding that's used to try and recreate the aurochs, which is the extinct ancestor of all of today's cattle, or the quagga, which was a subspecies of zebra that we know and still have in the world, but it looked a little bit different. It had a bare backside and a mocha-colored coat under its stripes rather than that white. And so in these 2 cases, we already have animals that are looking a lot like the extinct versions that groups have been able to backbreed into existence. And what backbreeding entails is a type of breeding process whereby, with the aurochs, for example, we know that this extinct ancestor of all today's living cattle was wiped out in the 1600s, but that its genome is still around, peppered among its descendants. So if you choose the cattle lines that most resemble it because they have the right horn shape and size and the right coloration patterns or the right differences in their body type between the males and females, for example, and you create breeding lines and where you cross those types of cattle together that most resemble the extinct one. Over many generations, you can actually start to see that you can precisely make these traits of extinct cattle emerge in the new animals that you're breeding. So it's a lower tech approach to doing de-extinction than what some of these genome engineering or cloning approaches can give us. But the idea is basically, if it looks like a duck and it quacks like a duck, then it's a good enough duck or aurochs or quagga or whatever other extinct animal you might be trying to breed from the related living animals that we still have today on the earth.
Well, one of the arguments against this that you mention in the book is the fact that there's a lot of money being spent on this and various types of research, but that money would probably be better spent towards conserving existing species rather than trying to bring back a species that's disappeared hundreds or thousands or millions of years ago.
Well, there isn't a ton of money going into de-extinction as it currently is, but the question is about harm to conservation programs. What would it mean if de-extinction were to take from conservation budgets as they're currently set up to help endangered species in the wild and divert those resources to come towards these more experimental approaches to doing conservation by trying to resurrect extinct genomes? So it's not, I just want to be clear about this because those who are doing de-extinctions, as George Church's group at Harvard working on the woolly mammoth, they say the biggest thing holding them back is money. It's that they don't have a ton of it because it's just a side project of their lab. Otherwise, they have the technology there and they could work much faster than they are. And now there's an organization called Revive and Restore trying to get a lot more money for their de-extinction project, for the de-extinction field as a whole, by making industrial partnerships with high-tech bioscience labs in order to scale it up from the university level of research to something that can actually be replicated and moved along faster. But that has held people back from wondering, could this cause harm to conservation resources that we already have? And actually, in just this past year, there was a paper published in Nature led by an ecologist and economist of conservation named Joseph Bennett at the University of Carleton in Ottawa, and they ran the numbers looking at, okay, with realistic conservation budgets from New Zealand and Australia that are already in existence for helping currently endangered species, what if conservation budgets from those monies were funneled off to help recreate close versions of these extinct species? What would happen to those endangered species that the money's originally there to help? And they found that if de-extinction does take from these conservation budgets, that they could have always saved at least 8 times as many species if they just left it to conservation as it traditionally is there, as compared with using the money to be able to help create these new kind of quizzical animals that you try and foster in the name of de-extinction. So basically, if you're interested in conservation, then their argument should be in increasing net biodiversity, no matter what that means. So the sheer amount of animals that you can help, that you can keep their biodiversity around for, should be your interest, not select interesting animals such as the woolly mammoth or the passenger pigeon or the aurochs or whatever your extinct animal example might be. Because if you can help more currently endangered species on the same amount, then you could, by making close versions of extinct species, you're not really doing biodiversity a favor because there will be a net biodiversity loss. It's a comparative question of how much good you could do on the same amount.
What about the idea of supposing somebody did, in fact, de-extinct or unextinct or resurrect, depending on the term you want to use, a species like the woolly mammoth and try to reintroduce it into the environment? What would that do to the environment? Could it possibly force another existing species out of existence, and the woolly mammoth that you've recreated is going into an environment that is possibly radically different than the environment that the original animal lived in anyway?
That's a great point, and that's one that does come up as a pushback point against de-extinction, which runs on a theory of ecological restoration. This idea being that if in an ecosystem you can locate a situation where there was a species had a really important functional role to play there that then disappeared, and some of the dynamics in that ecosystem went away when that species disappeared. And you can make an animal that mimics that extinct animal because you can bring its traits back by engineering them into the animal. Then you ought to do that and put it back into this ecosystem, which has lost some of its important productivity. The idea being that you would restore it and bring back something functionally beneficial to that ecosystem. That's a really, it's a contested theory by many conservationists, certainly because ecosystems are just on standby. Once a certain species disappears and goes extinct, it's not just waiting silently for something to happen. It's, of course, adapting to that loss, and it's moving forth in evolutionary time. So creating some kind of animal that's like an animal that could have been there over 10,000 years ago and reintroducing it won't necessarily have that effect of reverting the environment to what it was once like. It could create some new tertiary or, totally novel situation that the world hasn't seen before. But you mentioned the woolly mammoth, and that's a really interesting case because it's not very obvious at first to realize that why they want to recreate the woolly mammoth has to do with climate change and mitigating the bad effects of it. Because if you think of where the woolly mammoth used to roam, in the Pleistocene, places like the Yukon in Canada, but also Siberia and Russia, there are enormous swaths of land that just contain permafrost. And the permafrost is holding enormous amounts of carbon because there have been all these animals over millennia that have died there and fallen into the ground. But more importantly, all that vegetation that they've been feeding on, and that's just been in the environment, is locked up in these soils, and it's all made of carbon. But we've learned that permafrost is actually a bad term for these soils because they're not permanently frozen, it turns out. With the effects of climate change and the warming, we're seeing that these carbon stores are thawing, the permafrost is thawing, and then letting this carbon release into the atmosphere, which becomes very dangerous when we realize that there's twice as much carbon trapped up in these soils than is currently already in the atmosphere. And there are microbes everywhere that can turn this carbon into methane or carbon dioxide
and
to the greenhouse gas.
How would the woolly mammoth change this, though? I mean, if you reintroduced it there, what's the supposed benefit?
So there used to be more animals than there are now. There's a megafauna extinction that happened to take out the woolly mammoth as well as many other species. And if you think of these areas that have less animal productivity in them now, for much of the year, they're covered with snow. And snow can act like a thick insulating blanket that keeps things warmer on top of the soil than they otherwise would be. For example, than if you had millions of animals running around punching holes in the snow. So you can picture having many woolly mammoths back, running around with their big mammoth feet, perforating this insulating blanket, which creates these holes, allowing frigid air from the atmosphere to come down and hit the top of the soil. And basically, they would act like mobile ventilating systems, is the theory, running around to keep things colder and engineering that environment in a way that it's not without the disturbance of many woolly mammoths, for example. So it's a bit of a far stretch for some people to accept that, but proposed number is 80,000 woolly mammoths to try and have some kind of effect.
Well, I'm just curious, Britt Wray, as a scientific researcher, author, and so on, I'm just curious, what is your whole take, having done this research into what people are saying and doing, what's your take on this idea of de-extinction of animals?
I think that it is a fascinating technological project. I think that it drives a lot of awe and wonder and imagination. There's a reason why people are so attracted to this seemingly implausible idea of bringing extinct species into the world. And that motivates a lot of the science. But I think that when it gets couched as conservation, there's something not adding up there. This is first and foremost an interesting, neat, technological human step, but it is not what we need to solve the environmental crisis, the sixth mass extinction of species that we're currently in. It is not the answer to the biodiversity crisis that some people couch it as, is my personal opinion. Yes, from everything that I've learned.
Well, Britt Wray, thank you very much. It is a most interesting book, a very interesting look at an aspect of science that many people are not aware of that's actually going on right now. So thank you very much for this.
Thank you so much. Thanks for your interest.